Hello everyone and welcome. We'll be starting off on a series of videos for the AMC10 and 12, the American Math competitions, and both of these are going to be held sometime in the early to middle parts of November. If you are familiar with the format of the AMCs, you can feel free to skip past the next 1 or 2 minutes, but if not, I think it's good for me to just give a quick overview as well as a little bit of statistics on how the AMC is like. Now, before that, I would just like to make a quick announcement, which is that the center which I'm at, which is COCO, is hosting the AMC competitions in-house this year. So that is for any viewers in Singapore. If your school does not sign up for the AMC10 and the AMC12, you can sign up through our center. The details are given in a link below in the description, and you would be able to sit for the AMC10 and or AMC12 physically at our Red Hill Center. We will also have a 1-week class for both the AMC10 and the AMC12, which will be in the last couple of weeks of October. The details for those classes are also included in the description below. Now, without further ado, let's begin and look at the AMC a little bit more. The format is 25 questions, 75 minutes, each problem having 5 multiple choice options. Of course, this means that it would have been an obviously advisable strategy to just guess everything that you can't solve, but there are marks given for blanks, right? So the 1.5 marks for blanks makes things quite a bit different. And also, you don't get any marks for incorrect answers. Now, take note also that the problems are in approximate order of difficulty, which is why for this video, we are only looking at the first 10 problems. They should be quite easy in comparison to the last 10 questions, even more so than, let's say, for the Singapore Math Olympiads or some other regional competitions. Now, to give you a bit of an idea of the statistics, right, first of all, these are retrospective. So you won't know in advance how many marks you need to score, but it is usually in this ballpark. So a very common scenario would be something like you get 17 questions with 8 blanks. Now, this in theory should give you 114 marks, but you make 2 mistakes. So this would leave you with 102 marks because you lost 2 of your 6 marks. And that would be enough to, let's say, get you your distinction, the top 5%. Now, it's possible that you get another mistake, and if you get another mistake, that would still be enough for the AIME qualification. Of course, this is just a ballpark figure, so you shouldn't target an exact number of questions, but generally speaking, if you get about 100 plus marks, you are quite certain of getting into the AIME. Now, regardless of which of these is your target, we can say that the first 10 questions should be the easiest 10 questions, which is what we're going to look at here. So, as you can also see, the video is not that long. Let's jump straight in. For question 1. Now, this is just about handling things layer by layer. So, 3 and 1/3 is 10 over 3, and then after that you reciprocal it to get 3 over 10. Now you repeat that again, 3 and 3/10, and then you reciprocal it, now we are here, to get 10 over 33. And then you have 3 and 10 over 33, this is equal to 109 over 33, which is just option D. For the second question, Mike cycled 15 laps in 57 minutes. Assume he cycled at a constant speed throughout. Approximately how many laps did he complete in the first 27 minutes? You don't need to calculate this very carefully because constant speed, this is a bit less than half. Of 57, and so a little bit less than half means that option B should be the correct one. Now you have to be quick for the AMC because the later questions are not just harder, but also sometimes need more time to understand. These ones here, we can speed read and speed solve. So question 3. Sum of 3 numbers is 96. The first number is 6 times the third number, and the third number is 40 less than the second number. So both of these statements mention the third number, and so if they mention the third number, I think I can just go ahead and call the third number x, first number 6x, and the third number is 40 less than the second number. So these sum to 96. Solving gives you x equals to 7, and so your numbers 6x is 42, x plus 40 is 47, and your answer is 5, which is option E. Question 4 is a unit conversion question, which is a little bit annoying, but I think also not especially hard. So in some countries it's measured in liters per 100 km, while other countries use miles per gallon, and then you're given a conversion between km and miles and gallons and liters, just as M and L. So which of the following gives the fuel efficiency in liters per 100 kilometers for a car that gets X miles per gallon? So X miles per gallon. Now what I can do is I will convert this into km and liters immediately. So X miles, 1 mile is 1 over m kilometer. So X miles is X over m kilometers. And X over m kilometers is going to use up L liters. Now you want 100 kilometers, so these are directly proportional. I can just shift the m over, divide by x, and then multiply by 100. So 100 ml over x is going to be what we expect. Take note, ml is m times L, not milliliters, despite the unfortunate name. So looking at the options, this is going to be option E. Question 5, this is a tiny geometry question. For A, B, C, D, P, Q, R, S each lie on the side of A, B, C, D such that A, P, Q, C, R, S is an equilateral convex hexagon with side length S. Now take note, equilateral is not the same as regular. Equilateral just means equal lengths. So it is possible, let's say, to say that a rhombus is an equilateral quadrilateral, which is a bit of a tongue twister. Now my equilateral hexagon is supposed to include A and C, but not B and D. It goes A, P, Q, C, R, S. So I think it would look something like this. In order to be symmetric, it should look something like this figure over here. And what we want is that these are all equal in length. Now that's not very hard to do because the square has side length 1. So if I call this length x, it means that this should be 1 minus x and 1 minus x, and so you just get, oh I'm silly, right? It's called s. Never mind, let's use x then, because there's already a point s, so I didn't want to use s. So we just need to solve for x, but we do know that this is in a 1:1 square root 2 ratio. In other words, x is going to be square root 2 times of 1 minus x. which means that 1 plus root 2x is equal to square root 2, and x is equal to root 2 over 1 plus root 2, which is none of the options. But in order to get it to look like the options, we have to rationalize using the conjugate. And if you were to multiply out, the bottom will be 2 minus 1 is 1, and the top is 2 minus root 2. Now, question 6 is sort of a are you paying attention question. As long as you're paying attention, you will not go wrong. Now, the square root of a minus 1 squared is not a minus 1. Well, not necessarily a minus 1. It's actually equal to the absolute value because square roots, by definition, are not negative. So the square root of negative 2 squared, for example, is not negative 2, it is 2. We are told helpfully that a is less than 0. And so what that means is that your absolute value of a minus 1 is actually going to be 1 minus a. A minus 1 is negative. Now if I continue on inside my absolute value, this would simplify to 2a minus 3, which once again is actually negative without the absolute value. So with the absolute value, you have to flip it around, 3 minus 2a, and that is just option A. Now, one practical way to do a question like this, if you are more comfortable, is to just try a specific value of a, right? You could do something like also just try a equals to negative 5 or something like that, and just see what option the result is matching with. Question 7. The LCM of a positive integer n and 18 is 180. The GCD of n and 45 is 15. What is the sum of the digits of n? Now, there's not really that many things that you need to consider. So for a question like this, you can just almost look at the possibilities. But I think I'll try to explain how we can handle a problem like this in general, which is to do a prime factorization of just everything. So 180 is 18 times another 10, so another 2 and then another 5. So the next one is not LCM, the next one is a GCD. 45 is going to be 3 squared times 5, and this is 3 times 5. Now what we want to take away from this is that the LCM grabs the bigger power and the GCD grabs the smaller power for each prime, which means that for the LCM of n and 2 times 3 squared to look like this, the 2 squared and the 5 did not come from the 2 times 3 squared, so they must have come from n. For the GCD, the 3 did not come from the 3 squared, it came from n. So the conclusion is just simply n is 2 squared times 3 times 5, which is 60, and so your answer is 6. The AMC likes to do some things like that. They are a little bit careful, so they ask what is the sum of digits of n. Because if they just ask you what is n and give you 5 options, you could just test all 5 options. So this is their way of preventing you from simply testing all the options. Nonetheless, let's say if we see a question like this, we can use a divisibility test to say that n is not divisible by 9, so D is wrong. But n should be divisible by 3, so C is wrong. And sometimes you can still get a little bit of hints or eliminate some options just based on these sorts of small tricks. Question 8. This is data set of 6 not distinct positive integers, 1, 7, 5, 2, 5, and x, the average, which is the arithmetic mean, is supposed to be equal to a value in the data set. So this is a bit boring because it just could be equal to any of them. So the sum at this point is going to be equal to, if you add everything, is 20 plus x. Now we're saying that if the average is equal to one of these values, it means that one of these values times 6 is going to be equal to 20 plus x. So 20 plus x could be equal to 6 times 1. It could be 6 times 2. It could be 6 times 5. Or it could be 6 times 7. Or it could be 6 times x. So we just solve all of this, and you realize that, okay, hang on a second, the question says positive integers. So technically, we don't start there, we start below. This gives you x is equal to 10. This gives you x is equal to 22. And this gives you 5x is 20, so x is 4. So the sum of possible values is 36, which is option D. Question 9. You see that Microsoft Word for me is still in British English, so it thinks that color is spelled wrongly. But in any case, this is just asking you to color it with different colors, and you can repeat your colors as long as the regions that touch are different. Now I'm going to actually do something that I often like, which is to kind of convert this into what we would sometimes call a graph, but really it just means I represent each of the regions with a dot, and I just note down how they're connected. So this is actually what the region connections look like. Now, having seen this, what I'm going to do is I'm going to actually color it in not a left to right way, but I'm going to color this one first because this is connected to everything. So coloring this one first, I have 5 choices. And it also means that I only have 4 choices left for everything else, which makes my life a lot easier because I don't have to worry about if later on these two meet, then split into more cases. I don't have to do that because this will have 4 choices. Now this would be 3 choices because it cannot be either of those two, and same here, and same here. So you just multiply all of these together, 3, 3, 3, 4, and 5, and you will get 540. Last question for this video. You have got this rectangular card with diagonal 8 centimeters, and then after that squares of side 1 cm are cut at 2 opposite ends, and then after that the distance is now 4 square root 2. What's the area of the original card? Now I think this is probably the first place where we can do a little bit of algebra. Now I can let this entire height here be just x, and then the height across, sorry, that's very wavy, I can let that be y. Now that means that x squared plus y squared is 8 squared. And also if we look at, let's say, the smaller part down here, this would be x minus 2 and y minus 2, right? Because the corners have length y. So that means that you have got a second equation. 4 root 2 squared, which is 32, and this is 64. Now what you want is to find x times y. Now very often for some of these problems, it may be possible to just guess what are x and y, but I don't think it's that easy to do so here. So instead, all I'm going to do, since I can't guess x and y, is that I will subtract the two equations, but I can't really subtract it until I've expanded out the second equation. 4 and 4 is 8. So when I say subtract the equations, you're going to find out what is x plus y. Right, when you subtract off from the x squared plus y squared is 64, you're going to get 4x plus y is 40. So x plus y is 10. Now if x plus y is 10, then x squared plus y squared is 64. We can get xy just by the usual manipulation, x plus y squared minus x squared plus y squared. And this would give us our answer, which is 18. Okay, so that's our first 10 questions in not a lot of time. And for those of you, especially if you are aiming for the distinction on a roll, or you're aiming to get just a very high score, you would like to be able to finish it roughly in this sort of time frame of 15 minutes to 20 minutes for the first 10 questions to buy yourself a lot of time for the harder later problems. Okay, so before we end off, again, just a reminder to our viewers from Singapore that you can sign up for the AMC competition through our center at the link below in case it is not offered in your own secondary school. And also, we will have classes, but for now, just feel free to enjoy our reviews of these recent AMC10 problems. So please also like and subscribe to support the channel. Thanks for watching, and see you again soon for the next part of the AMC10A paper.